This is chapter 3, day 3, inequality notes. These are or compound inequalities. All right, so these are or. So remember what or means. Or means one or the other, right? Like if I say, if you want to get an A in math, you can give me $9 million or you can buy me a Jaguar. That means you could do either one of those things, right? That's what or means. So here for these or inequalities, what you do is you just solve both of them and then you graph them on the same number line. So here we have like 5m is greater than or equal to 25. We know we'd solve that by dividing by 5. So we get m is greater than or equal to 5, or, so you can either be a number greater than or equal to 5, or if I solve this other one, m divided by 8, I know I'd multiply both sides by 8. So I get m is less than or equal to negative 8. So you could be at any one of those places to make this work. So you would just graph both of those on the same number line. So I'd go to where 5 is, put a dot, I'd fill it in because it's equal to, and shade to the right because it was greater than. So I could be here, or m is less than or equal to negative 8. The negatives don't show up on this program, I don't know why, but here's negative 8. I would be filled in because I'm equal to, and then to the left because I am less than. So the numbers that work for these are any of the numbers that are up here that are greater than or equal to 5, or that are down here less than or equal to negative 8. So like 10 would be a winner, negative 10 would be a winner, 0 would not because it's not shaded in at 0. All right, so same thing here on this next one. To solve, I would start by dividing by 4. So when I divide by 4, I get a is greater than or equal to negative 4. Or, and you have to have that or word in your answer, to solve a minus 5, I would add 5 on both sides. So that one gives me a is less than negative 6. Ha, nice writing. So those are my two possibilities, right? So a is greater than or equal to negative 4. Again, the negatives don't show up. Sorry about that. Don't know why that happens when I do this program. So dot at negative 4, filled in because it's equal to, shaded to the right because it's greater. So I could be here, or a is less than negative 6. I'd have an open dot at negative 6 because it's not included, it doesn't have the line, and I would be less than. So I could either be in this space over here on the left or this space up here on the right. Look at another one. So number 3 here, maybe I'll start writing underneath here. So to get rid of that positive 10, I'd start by subtracting 10 on both sides. So that gets us to 7v is greater than 56. So then to get rid of a multiply by 7, I divide by 7. So I get v is greater than 8. Or then I would solve the second one. So on the second one there, then I'd start by subtracting 7. I'll write it down here like I did on the last one. I think it's easier. Or you could just rewrite the whole thing. So when you subtract 7, I'm looking at negative 8v is greater than or equal to 87 minus 7 is 80. To get v alone then, I would divide by negative 8 because he's being multiplied by negative 8. I just heard in my brain divide by negative, so I got to flip. So v is less than or equal to 80 divided by negative 8 is negative 10. So then there's my two possibilities of where I could be. So v is greater than 8. I'd have a dot at 8. Dot is open, shaded to the right. So there's representing all the numbers that are greater than 8. Or v is less than or equal to negative 10. I'd have a dot at negative 10. I would fill in the dot because it is equal to, and then I would shade to the left where all the numbers are less than. So I could either be hanging out down here on the left, less than or equal to negative 10, or hanging up here on the right, greater than 8. So number 4, let's see, we're solving. So I'd start by subtracting 3 on both sides. We've got a two-step equation here, actually a two-step inequality. So then we have 5r is greater than 48 minus 3 is 45. To get rid of the multiply by 5, we divide both sides by 5. So we have r is greater than 45 divided by 5 is 9. Then we'd have our or, so that's the first thing that could happen. Or, let's see, second one here, we're going to start by subtracting 10 on both sides. So then we're looking at 4r is less than negative 10 minus 10 is negative 20. To get rid of a multiply by 4, we divide by 4. We're dividing by 4, so we don't flip the inequality. We get r is less than negative 20 divided by 4 is negative 5. So there's my two possibilities. I can be greater than 9, so I'd have an open dot at 9, shaded to the right. Or I could be less than negative 5, so I'd have an open dot at negative 5, shaded to the left. There's my two possibilities. All right, so it's just the inequalities that are getting a little more complex here. Actually, these are two-step also. So I'd start number 5 here. To get rid of a minus 7, I'm going to add 7 on both sides. So then I have 7a is, ooh, nice 7, Miss Cole. 7a is less than negative 21 plus 7 is negative 14. To get rid of a multiply by 7, we divide by 7. So I divided by 7, so no flipping. A is less than negative 2. Or, now I got to solve the other one. So let's see, to get rid of a positive 2, I'm going to subtract 2 on both sides. So then I'm looking at 8a is greater than or equal to 2 minus 2 is 0. Get rid of a multiply by 8, I divide by 8. So a is greater than or equal to 0. So again, there's my two possibilities. A is less than negative 2, so open dot at negative 2, shaded to the left. Or A is greater than or equal to 0, so close dot at 0 because 0 is included because of the equals, shaded to the right. All right, let's look at one more, uno más. So let's see. Oh, this one is a little more difficult. We've got variables on both sides. So we're going to go n on the left, no n on the right. So I have to move the minus 7 by adding 7. I would add 7 to the 5 on the other side because those are the no n's, the constants. So we have 2n greater than or equal to 5 plus 7 is 12 minus 2n. So my n side looks good, but my no n side over here, I got to move the minus 2n by adding 2n. So I add 2n on the right, I got to add 2n on the left. So 2n plus 2n is 4n is greater than or equal to 12. So when I divide that by 4, n is greater than or equal to 3. Or I got to solve the other one. Again, we're going n on the left, no n on the right because we have variables on both sides. So to get rid of the 7, we're going to subtract 7 on both sides. So we've got 5n less than n. Negative 5 minus 7 is negative 12. So now we got to get this n over to the n side. So to move a positive n, we're going to subtract n. Remember, when there's not a number in front, there's an invisible 1. So 5n minus n is like 5n minus 1n, which is 4n, is less than, don't lose your negative over here, we have negative 12. So the negative 12 divided by 4 gives us n is less than negative 3. So there's our or compound inequality. So n is greater than or equal to 3. We'd go to 3, put a dot, fill it in because it's equal to. The numbers greater than 3 are to the right. Or, so I can be hanging out up here, or n is less than negative 3. Again, the negatives don't show up. I don't know why, it's weird. So that's our negative 3. That's where it would be. Open because it's not equal to, and shaded to the left. So those are compound inequalities called ORs. There's another one called AND that we'll look at next. But this was Chapter 3, Day 3, compound inequalities that are ORs.